And today we are discussing cybersecurity. Ooh. So, the problem that we are encountering is because of the way the internet is built, the way that we send information across all these routers, all of the information that we send is sent over shared wires. Information like your credit card number, your passwords for various things, any emails you might be sending or receiving. You might be giving someone your social security number online. Now, all of these things are very important, and if they were to fall into the wrong hands, it could be disastrous. So if we don't protect this information somehow, it could be read by a cyber criminal. So we need to prevent cyber criminals from reading our data. So all of these lines, cybercrime and cyber warfare are very serious threats that have some very devastating effects on our world at large. Cybercrime has to do with attacks against individuals, where cyber warfare has to do with attacks at more of a military level, at a national level. So some instances of potential cybercrime. These are crimes being perpetuated by cyber criminals. They could perform identity theft. They could steal money by stealing credit card information. They could steal your private information and do identity theft, pretend to be you online and do things that you wouldn't normally do. They can take control of people's private computers to steal their information or perform any number of different nefarious actions with them. In cyber warfare, this is often going to involve hacking into government computer systems and taking control of things like communication, transportation, water, or energy production, or interfering in the elections of other countries, which, once again, could be potentially super detrimental. So cybercrime, cyber warfare are really not very good. We want to prevent these things at all costs. We want to do everything we can to stop them from happening. Some examples of cybercrime, a DDoS attack, or DDoS, which stands for Distributed Denial of Service. And it involves having a whole bunch of computers spam a web server with so many requests that it crashes because it cannot handle all of these incoming requests. Sometimes servers will spit out valuable information as they're crashing because everything is going wrong. So they might just start spewing things that they aren't meant to. Sometimes these attacks are just performed out of spite against an individual or a company. If a group of people are mad, or if a single hacker is mad, they might hijack a bunch of computers and have all of those computers send thousands and thousands of requests onto a single server. It's called a denial of service attack because the website that you're attacking is made unavailable because its server has crashed. It's not going to be able to field any requests since the server is down. And it's distributed because the attack is coming in from a large number of different computers. Sometimes it's people coordinating with each other to deny the service of a website, or it's a single hijacker who has taken over a bunch of computers and is sending all of these requests. Another type of cybercrime is DNS spoofing. So if a cyber criminal somehow manages to get in between you and a DNS name resolver, remember the system that we use to find the IP address for given website, it's possible for them to feed your computer an incorrect IP address. Maybe it's for their own personal web server, which might look like the correct website, but it is definitely not Facebook or Google or Twitter or whatever. If they can get you to visit this false site, they might be able to install malware. They might be able to scrape your personal data or any other number of malicious things. So we want to, once again, avoid hitting these incorrect IP addresses. So what solutions do we have in place to prevent these kinds of attacks? The answer is cybersecurity. There's several different things that go into this. There are protocols for encrypting and decrypting data. So in addition to just protocols for sending our data and distributing the packets, all these different things, we have different protocols in place for actually making sure our data is encrypted, scrambled up before we send it. So that if someone intercepts it halfway through it's being sent, they can't read it. They can't see what the contents of the message were if they happen to snag it in the middle. We can use security software like antivirus software, programs that are designed to help your computer defend itself from cyber attacks, finding whether or not viruses have been installed, all these different things, and just removing malware. And in general, we want to follow the best practices that are in place for use of the internet. Most cybersecurity breaches are going to occur due to human error rather than software having an issue. So if we can close the loop, if we can prevent ourselves from making these errors, we can prevent a lot of cyber attacks. So one of the biggest contributors to this cybersecurity equation is encryption. And we might remember back from last unit, from I guess last semester, we talked about cryptography, where we are scrambling messages so that they aren't able to be intercepted and read. There are several open standards of encryption of information for sending it across the internet so that every computer understands how we're supposed to encrypt and decrypt data, just like how we're supposed to package data. So the primary protocol used across the internet today is SSL/TLS, and this stands for Secure Sockets Layer and Transport Layer Security. So in general, the way that this works is we can tell, I will get into how it works in just a minute, one sec. We can tell when we are using a secure communications when we have an HTTPS in our URL. So if we see that S after our HTTP, it means we have a secure connection. We're communicating securely with this website. So if we remember back to our public key encryption from the cryptography lesson, SSL and TLS use public key encryption to ensure that we are sending information securely. So in this encoding schema, we remember the public key is going to encrypt information and the private key is going to decrypt information. So if Alf wants to send a message to Jeff, Alf is going to get Jeff's public key. Alf is going to encrypt their message using Jeff's public key, send the message over to Jeff, at which point Jeff will be able to unlock that message. They'll be able to decrypt it using Jeff's private key. Now, only Jeff, or rather Jeff's computer, should have access to that private key. While anyone can request access to Jeff's public key, it's not useful for unlocking a message. So only Jeff's private key is going to be useful for unlocking a message that was encrypted using Jeff's public key. So if a hacker happens to intercept the message as it's being transmitted across the routers from Alf to Jeff, since they do not have Jeff's private key, they aren't going to be able to decrypt the message. Now, certificate authorities, or CAs, are another very helpful component here. CAs are going to verify the public keys of the websites that you visit. So if you're trying to communicate with a website, you're going to get their public key, and you're also going to make sure that that key is actually the website's public key. So you're going to check it against what the CA says to confirm that this is the right key. This way, if a hacker happens to intercept our transmission and sent us a key maybe to their own server rather than the actual public key for the website we wanted to visit, our public isn't going to send any messages using that incorrect key that the hacker gave us. We're only going to use the correct one that the certificate authority has certified. Now, security software is another fairly large component. Sometimes, if we're not following those internet best practices, we might download a program that someone malicious wrote to try and steal our information, or potentially do something else bad with our computer, like use it in a DDoS attack. These programs are called viruses or malware. I'm sure you've all heard of those things. To combat these types of programs, we can install antivirus software, which is designed to detect and delete these malicious programs off of our computers so that they can't be used to harvest our data or be used in these kind of attacks. Now, one of the biggest things we can do is, in addition to all of these systems that are built into the internet or built into our computers, there are things that we ourselves can do to keep ourselves safe. Thing one, we can use strong passwords. And this is another XKCD comic about passwords, where if we look at this first panel, we have troubadour and 3. So we have an uncommon word with a numeral and some numbers with some replacements for the common letter replacements. And this is the general style of password that we've been recommended. But if we look at this little diagram, there's not too many different places of potential entropy. So places where a computer might have a hard time guessing. Now, if we have a whole bunch of random words, there are lots of different places where it's harder to guess what this password might be. So we want our passwords to be very difficult for computers to guess, as well as easy for us to remember. So in addition to having strong passwords, we also don't want to use repeated passwords between websites. If a website happens to get hacked, which does happen not infrequently, your password could be leaked to those hackers. And if you use the same password on multiple accounts, the hacker might be able to try that password on various different websites and gain access to all kinds of different accounts. So you want to make sure that your passwords on different websites are distinct from each other so that hackers can't use that one password if they happen to get it on different websites. Now, a tool that I personally use is a password manager. This is a great tool to solve both of these problems: strong passwords and repeated passwords. You can have this password manager generate a unique, strong password for every single website you visit, and then you only need to remember the one password for that password manager in order to be able to access all of your passwords. So that's just a suggestion on how you can improve your own personal internet security. Use a password manager. If you ever on a device have a notification saying, hey, please install these security updates, usually you're going to want to do that because they're often going to fix vital security breaches that have been found by the developers of your software. And it's very important that you don't just keep clicking, yeah, I'll do it later, remind me later, over and over, because it's possible that in the time that you aren't updating, a hacker could find your device and exploit that loophole, exploit that security breach to gain access to your device or your software. So it's very important that we install our security updates. And last, we want to make sure we think twice before we click on any suspicious links or download anything fishy. So if you get an email from someone you don't know, maybe you don't click on links in there. If you visit a website and your browser's like, hey, maybe don't go there. Maybe don't go there. And if you're trying to download a file and your browser says, hey, maybe don't download that. Maybe you shouldn't download that. Usually following the prompts that your browser gives you, any warnings that it says, usually a good idea. Browsers have been built with the idea that we want to surf the web, but we also want to keep our users safe. Gap guard lights. as I said, one of the largest holes in our internet security is often the human element. It's often us. So attacks against the user of the internet are called phishing with a PH. And there's all kinds of different attacks that can be carried out by phishing people. People can pose as someone you might know in an email, asking you to click on some link. There might be a website that looks like another website, maybe eBoy instead of eBay. And they have you type in your email and password, and then they know your eBay email and password. You might get a voice call asking you to call a specific number or visit a specific website. I know I get all kinds of phone calls saying your warranty is expired or your car is out of date or something, and they want me to call a number. They want me to go to a website because they think I am gullible enough to do that. Clearly, I am not. Microsoft tech support websites, absolutely. There's all kinds of like people who will try and con you into going to a or a tech support website just to steal your information or get you to send them money. So there's all kinds of different scams that people can try and pull on users. If they don't need to hack into anyone's device if they can go through the easiest point of access, which is the user. So remember to be smart. Remember, don't just click on random things. Listen to your browser. Don't listen to anyone who says they're a Nigerian prince. Very correct, Logan. We do not know any Nigerian princes. I doubt any Nigerian prince is going to try to reach out to any of us. So just ignore those emails and mark them as spam. Delete them. Don't be the weak link in your own internet security. All right. Any questions on cybersecurity? Cool. All right.